Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we are looking at multiplying and dividing square root radicals. Today, I'd like to pick up with classwork examples 8, 9, and 10. In class today, we had developed the division property of square roots, which you see here. It says that the square root of a number a divided by the square root of a number b is the same as the square root of the quotient of those numbers a and b. When we encounter these types of problems that have coefficients, we want to deal with the coefficients separately and the radicand separately. So if we wanted to do 12 radical 252 divided by 3 radical 7, we would do 12 divided by 3 times radical 252 divided by radical 7. So we do coefficient by coefficient. 12 divided by 3 would give 4. And then radical 252 divided by radical 7. Here we would want to apply the division property of square roots, So we really want to think about this one like this. It's really the quotient of 252 divided by 7 under a single square root radical. We divide 252 by 7. I'm pretty sure we get 36. And since 36 is a perfect square, we can take its square root, which is 6. 4 times 6 would leave us with 24. So this expression simplifies to 24. In looking at example 9, we need to be careful here because 80 is a radicand and 4 is a coefficient. We do not want to divide radicand by coefficient or coefficient by radicand. Now, the coefficient in the numerator is a 1. So we have really 1 radical 80 over 4. To help us simplify this one, what we'll want to do is look to find a perfect square factor for 80. 80 has come up a lot. I think it came up twice in class today. 16 and 5 would be your factors. 16 being the biggest perfect square. It's a factor of 80. And the square root of 16 would be 4. So we have 4 times the square root of 5 over 4. Now we can do some division. 4 divided by 4 would be 1. Division of coefficients. Since there's no radical expression in the denominator, we'll end up leaving radical 5 as is. So the answer to this one would just be plain old radical 5. We see a similar setup here in example 10. We have no radical expression in the denominator, so we'll focus in here on the coefficients. 6 divided by 2 would be 3. So we'd be left with 3 radical 52. And from there, you'd want to look for the largest perfect square factor of 52, which is 4. The other factor being 13. Now, some of you mentioned in class about why would we not put 13 in the first radical? Because it's larger than 4. Well, remember, when we're looking for the larger number, we're referring to the largest perfect square that's a factor of the radicand. The largest perfect square that's a factor of 52 is 4. So even though 13 is larger than 4, 13 is not the perfect square. The non-perfect square we prefer to have in the second radical because we're going to extract the square root from this expression here. So this would be 3 times 2, 6 radical 13. Well, I hope this was helpful to you. I'll see you in class tomorrow.